3.3.3 second shifting property. If a less than 0 and Laplace transform f of t is fs, then Laplace transform f of t minus a u of t minus a is exponent negative as Laplace transform f of t equals to e negative a as fs. Okay, again, this table 3.3 will be used one more time. And example 3.3.2, find Laplace transform t minus 5 minus u of t minus 5. Okay, how to solve this question? Okay, if we look at here, a is 5 and ft is t, ft, and fs equals to Laplace transform f of t. We can refer here. Fs here equals to Laplace transform f of t, and equals to Laplace transform of t from here. ft equals to t, ft equals to t, and previously we already done. If Laplace transform of t is 1 over s squared, so Laplace t minus 5 u of t minus 5, we compare with this property, okay, where the a here is 5, and then we can have exponent e negative 5s, refer to this, and fs, we have fs is 1 over s squared, 1 over s squared. Okay, the second one, find the Laplace transform t u of t minus 5. Okay, if you look at here, t here is single, then we need to do a bit work to make it equals to t minus 5, to make them equal. So this is the way. From t alone, we minus 5 and plus 5. Minus 5 plus 5 equals to 0. So it is same with the original one. And u t minus 5. Okay. Now you can multiply t minus 5 multiply with u t minus 5, and then plus 5 with u t minus 5. Okay, now we can have A is 5 and Ft is t, Fs is 1 over s squared. So we can compare with the third property, since here our A is 5, so we can have E negative 5s 1 over s squared. Second one, 5 here, Laplace u of t minus 5, we refer to the second property, ut minus 5, ut minus a. Here a is 5 equals to 1 over s e negative 5s. Okay, we proceed with another example. Laplace transform u t minus 1, u of t minus 1 minus t minus 2, u of t minus 2. Okay, first we can see that 2 here. We can bring the 2 outside and then do the Laplace transformation separately, since there are 2 components here. Here I do the transformation separately. And now we can compare with the second property, not the third property, second property. A here is 1. A here is 1, and then another A is 2. So the first component we have E 2E negative s, because our A here is 1, multiply with LT, where Laplace of t actually is Fs, and E negative 2s Laplace of t. Again, Laplace of t is Fs, which is equal to 1 over s squared. Therefore, this is the answer. 2e negative s 1 over s squared minus e negative 2s 1 over s squared. Okay, the last part is how to write f of t in the form of unit step function. Okay, you are given that if t is between 0 to a equals to f1t, and if t greater or equals a is f2t. So this is the way how to write the unit step function. F of t is f1t plus f2t minus f1 f2 with minus f1 u t minus a. Okay, look at the example 3.3.4. Write function of t in terms of unit step function and find its Laplace transform. So there are 2 questions here. The first one, we need to write a unit step function ft, which is we copy the formula here and then we replace f1t with e negative t plus f2 to t minus 1 minus f1 e negative t u t minus a. So we have this. Now we can expand one more step. 2t minus 1 multiply with ut minus 2 and e negative t multiply with, okay, so we have this. Okay, now how to do the Laplace transform? Okay, we can see that this part a bit challenging because we have -1 and -2, which is the values are not equal. You need to do a bit more work to solve for this. And okay, to find a solution, I believe you can understand if you refer to your textbook, page 66. And I would like to ask you to do all the exercises in the module or the textbook. For further questions and further discussion, you can always WhatsApp me or do send me a text. We can have discussion. Thank you.